we have the property a to the b plus c equals a to the b times a to the c. We see that addition of exponents leads to a multiplication. Inverse property, well, these are exponents. You would expect the inverse property to have something to do with logs, and you can think through the details. But the inverse property is where a multiplication gives you an addition. So that the log of a times b is the log of a plus the log of b. The inverse to the property that says 10 to the a plus b equals a to the b times a to the c. The multiplications and additions work in opposite ways there. A to the b raised to the c is a to the b times c. So you got a power of a power implies a multiple of powers. Okay, well, if you take the log of a power, that becomes a product of the power and the log, okay, in the way that you see here. Now, whether you understand this in its relation to the exponential, to exponentiation, or just memorize these two properties, that's what they are, okay? There are some false rules. It doesn't say anything about the log of a plus b. You don't have a rule for that. But it's certainly not equal to the log of a plus the log of b. The log is not a linear function, okay? So if you're tempted to write this down, this is a fallacy. It's false. Avoid it like poison, along with the others, okay? It'll poison your problem, okay? Leading to not many points, okay? Also, log of a plus b is not equal to the log of a times the log of b. It's the log of a times b that's the log of a plus the log of b, and that's because of the way the exponents work. Then, log of a to the b is not equal to the log of a raised to the b. It's equal to b times the log of a. Okay? So you got to be very straight on these because it's really easy to write things down incorrectly. Okay? And I demonstrated that by pretending to make a mistake when I solved one of the problems. Okay?
Yeah.
I was thinking through all the ways the problem could be solved, and then I wrote something down really stupid. Okay, but I do it all the time, so that won't be a shock to anybody. Okay, so. Okay, what do you do with the log of x times 8? Which property applies to the log of x times 8? Well, that'd be a log of a times b, right? It's certainly not, there's no power involved, so it's got to be this. And the rule says that that's got to be the log of a plus the log of b. In other words, the log of x plus the log of 8. Now here it is written out in more detail with more explanation, if you want to hear more explanation, but it's a very straightforward application of the property. Okay, now let's consider the log of 5 times 2 to the 7th. What property applies? Well, you have a log of something times something. That's this property, right? And this property tells you that's a log of the one something plus the log of the other. So log of 5 times 2 to the 7th is the log of 5 plus the log of 2 to the 7th. But now we've got the log of 2 to the 7th, and we can apply the second property to that. So the log of 2 to the 7th by this property is 7 times the log of 2. Okay? So the log of 5 times 2 to the 7th simplifies to, or expands if you wish, to log of 5 plus 7 times the log of 2.